Hello and welcome to this new lesson on Pythagorean Theorem. So we're starting a new unit on the Pythagorean Theorem. There is 4 different lessons about the Pythagorean Theorem. Each one has a kind of a different theme. This one is just a basic straightforward Pythagorean Theorem problem. The next problem is going to be kind of applications and word problems, sort of. The next lesson is going to be the converse of the Pythagorean Theorem. And then the 4th lesson is going to be the distance formula. So let's go ahead and get started. So first off, how do I use the Pythagorean theorem to determine unknown lengths of right triangles? And really, that is like the whole point behind the Pythagorean theorem is if you have a right triangle and you know, I'm just making up some numbers, and I know 2 out of the 3 sides, we can use this Pythagorean theorem to find out, well, how big is this third side? Some caveats. It has to be a right triangle, guaranteed 100%. If it's not a right triangle, you cannot use the Pythagorean theorem. Did you know that the Pythagorean theorem has been around for over 2,500 years? It was proved by Pythagoras of Samos. That's how it got its name, the Pythagorean theorem, Pythagoras. Although the concept existed long before Pythagoras, it does have many uses. Here are a few. So, finding the missing side of a right triangle. It's kind of boring. That's how we're going to be using it, but it's there. Finding a distance in real life. GPS does this all the time. Make sure a door frame is square. It's used in carpentry a lot, Pythagorean theorem. I've used it quite a few times in carpentry and building various things. Find the distance between 2 points on a grid, kind of graphing. We'll be doing a little bit of that as well. And in general, it's finding distances is kind of what it does best. It's the whole point of it is it finds how far apart a couple things are, a couple points are, or things in real life. So vocabulary. First off, a right triangle is a triangle with a 90-degree angle. Again, it has to have, ooh, that was terrible. It has to have the little box in the corner. The little box in the corner means that this is a 90-degree angle. This is a right angle. If there's no little box in the corner, then we can't do the Pythagorean theorem. So what is the Pythagorean theorem? Well, the Pythagorean theorem is this formula right here. So this you might want to mark off and star and square and put smiley faces and stuff into, highlight it. That's the formula we're going to be writing down in every single problem. It's also provided for you on your formula sheet. So if you need to look back at it, this is not a formula you necessarily have to remember, although we'll be using it so much that you will almost definitely remember it. So it's a squared plus b squared equals c squared, where a and b are legs of the triangle. Those are the short sides. So out of this triangle, these 2 are the short sides, the one connected to the right angle. These would be like your A and B, and C is the hypotenuse. That would make the long side the hypotenuse. Speaking of which, that's our 3rd vocab word. The hypotenuse is the longest side of a right triangle, not connected to the right angle. It's always diagonally across from the right angle. It's that one. Whatever's across from the right angle, that will always be your hypotenuse. Because it's actually true that in a triangle, across from the largest angle is the largest side. Across from the smallest angle is the smallest side. So let's see how this Pythagorean theorem works out. So we want to find the length of the hypotenuse. I want to find out how big this piece is. So find the length of the missing side of the triangle. Figures are not drawn to scale, meaning if you actually measure this, obviously it's not going to be 12 feet and 5 feet. I just drew some triangles and threw some side lengths on them. So you can't always go by what the picture looks like when you're doing kind of geometry type problems. So here's how the Pythagorean theorem works. First off, we write down the formula. A squared plus b squared equals c squared. We plug in our sides. The only side that makes a difference when you're doing Pythagorean theorem is the longest side, the one across from the right angle. That always has to go in for the c. The hypotenuse, that's reserved for the hypotenuse right there. So I'm going to plug in my x. Now the other two sides, the two legs, the 5 and the 12 here, they can go in for a and b interchangeably. It doesn't matter if you put the 5 here or there, and same with the 12. Okay, so I'm just going to plug in 5 squared plus 12 squared equals x squared. Okay, now we can do math in our head. 25 plus 144 equals x squared, and that's 169 equals x squared. Or we can use our calculator. 5 squared plus 12 squared. So I typed this in the calculator, and I got 169. Again, that came from, if you're doing this by hand without a fancy calculator, well, I've got the hiccups, you would get 25 plus 144 equals x squared. That's 5 squared is 25, 12 squared is 144. And then, well, how do we solve this? How do we get this x squared to be just plain old x? We did this a long time ago. Do you remember? It's this right here. It's square root. If we square root both sides, we're going to get x equals. The opposite of squaring is square rooting. These two symbols are opposites. These two operations are opposites. So now we have just x. And maybe you remember that whenever you square root something, you always get a positive and a negative answer. Do you remember that? If you don't, it's true. We did learn about that. Whenever you take the square root, you always get a positive and a negative answer. But I didn't actually square root. I just copied the number down. Let me try that again. 13. Square root of 169 is 13. I forgot. My bad. All right. Now, back to what I was going to say. I got excited about the negative thing. So, it doesn't make sense to have a negative 13 feet here. I mean, I've never measured something and got a negative number. Rulers don't have negatives. So, that's one reason a lot of times when we're dealing with square roots, we kind of drop the negative thing. Because a lot of times, a negative answer doesn't really make sense. So we're going to ignore the fact that there's a negative there, but I wanted to highlight and remember that there is technically a negative when you take the square root. But that's it. That's the whole problem. So we wrote down our formula. We plugged in our numbers, making sure our longest side went in for the c. Then we simplified, solved the equation by square rooting, and there we have our answer. And I guess I should be a good boy and throw my labels in my answer. That's 13 feet. And there we have it. Okay, letter B. So we start by writing our formula. A squared plus b squared equals c squared. I plug in my sides. I reserve the longest side for the c. I plug the other two sides in for a or b interchangeably. So 3 squared plus 4 squared. I simplify. 9 plus 16 is y squared. I know that 9 plus 16 is 25. And I know, actually, let me do this. I'm going to change my highlighter to blue. There we go. When I square root both sides, I'm going to get y equals 5. A lot of these problems you'll see you can do in your head, at least in this lesson. Most of the answers are going to come out to be nice, pretty numbers, whole numbers. Not always. So don't be confused if you get decimal answers and fraction answers and stuff like that. It's okay, that's allowed. But at least in this lesson, this kind of introductory lesson, they're almost all nice, pretty answers. Okay, here is one for you to try. So I'd like you to pause the video, and I'd like you to find out how big side Z is. When you're ready to continue, hit play, and we'll go through it together. All right, so let's see. We have a squared plus b squared equals c squared. My pen's not writing very good today. All right, I am going to put the longest side, the z, in for the c. So there's z squared. The other two sides, the 24 and the 7, go in a and b interchangeably. So 24 squared plus 7 squared. I don't know what 24 squared is, so I'm actually going to use my calculator here. And I might as well just type the whole thing in while I'm doing it. So 24 squared plus 7 squared is 625. And then to solve our equation, we're going to square root both sides to make the z squared just a plain old z. So if I square root 625, I get 25. So this side is 25 yards long. Now, not always will our hypotenuse be the side that's missing. It's not always going to be the longest side. It's not always going to be the C. There are times, like here, for example, we're not missing the longest side. I know this is still going to be side C in my formula, but I know how big it is now. It's 10. What I'm missing is one of the legs. The good news is the formula is the same. The steps are almost exactly the same. So a squared plus b squared equals c squared. I plug my longest side in for the c first. And then my other two, my 6 and my a, go in a and b. And no, you don't have to plug the a in for a. If you want to be different, you can plug in a for b, whatever. I like to plug in the variable for the first piece. That's just my style. So a squared plus 6 squared. Now we simplify and solve. So this becomes a squared plus 36. That's 6 times 6 is 36. That's 6 squared. Equals 100. 10 squared is 100. 10 times 10. Now when I solve this equation, before I can do the square root thing, I need to get rid of this plus 36. So I subtract 36 on both sides. A squared equals, I'm going to say that's 64, but I'm going to double check it. Okay. Now we square root. So the only difference was here, we had to kind of get the a squared, the variable squared piece by itself. So there's one extra step right here. And then we're going to square root like we did before. Ba-boom, ba-boom. And we get a equals 8 miles. One thing I like to do is I always like to write my numbers, or not always, I like to write my numbers next to my problem back up in the picture. Because sometimes looking at the picture, you can see, oh man, maybe my answer didn't really make much sense. I mean, here, if I would have got an answer of, say, 12, well, I know this can't be 12 because 10 is the biggest side. So if I got something bigger than 10, I made a whoopsie. More than likely, the whoopsie is plugging the numbers in the wrong place in Pythagorean theorem. I know a lot of students who don't really pay attention to what the longest side is, and they just plug in the numbers for the a and the b and plug the variable in for c, and that's going to get you a wrong answer a lot of the time. Okay, letter B. So a squared plus b squared equals c squared. My longest side, I'm plugging in for c first. The other two sides, I'm plugging, oops, not equals, plus 15. There we go. So the D and the 15, I just plugged in A and B. I like to put the variable first. So then I don't know what D squared is. I do know what 15 squared is. That should be 255. Oop, 225. Good thing I checked. 225. And 17 squared is like 189, I think. 289. My brain is off this early in the morning. See, I'm recording at 7:25 in the morning. I woke up early here to do this one. Let's see. I'm going to solve the equation, so I subtract 225 on both sides. D squared equals 289 minus 225 is 64. Ooh, I can do the rest of this one. Because now when I square root both sides to get the D by itself, I get just D equals 8. And it is 8 kilometers. And I'm looking at my picture quick and everything looks good. I mean, that is the shortest side. That's the smallest number. You can't always rely on that because a lot of times they'll just draw the random pictures. I do that a lot of times too. Like this side doesn't necessarily look smaller than this side, but in general, the picture looks okay. Okay, so you've seen 2. 1 for you now. So go ahead and pause the video and do letter C here. When you're ready to continue, hit play and we'll go through it together. All right, so let's see. A squared plus B squared equals C squared. The longest side is the one across from the right angle. That is my C, so I plug in the 26 squared there first. The other 2, I just plug in for A and B. Double check that step. Make sure you have your 26 in for C, because that's the one place that a lot of students kind of make a mistake when they first do this, is they mess that part up. If you got that, you should be fine the rest of the problem, I would think. I don't know 26 squared. 676. That's a 7. I subtract 100 on both sides. I get K squared is 576. And then I'm going to square root to get the K by itself. And I get K, well, square root of 576 is 24 inches. And I write it back up here, 24 inches, and it looks good. I mean, it's bigger than this side. That's definitely the biggest side. Like everything there looks fine. Okay, that's a step a lot of students don't do, is they don't just check to see if their answer makes sense in the end. Skill check. How do you use the Pythagorean theorem to find the missing side of a right triangle? Think about that real quick. See if you can write down a sentence. Like, I don't need a lot, just a thought. How do you use the Pythagorean theorem to find the missing side of a right triangle? Think about it right now. So you write down your formula. You plug in the sides for the A, B, and C, making sure that the hypotenuse goes in for the C, and then you solve the equation. That's what I would put. I'm not going to write that all out because it would take me a while, and you don't need to watch me write, but that's what I would say. Write down the formula, plug in your sides into the formula, making sure the C is for the hypotenuse, the longest side, and then solve the equation. So a couple little applications. These are fairly straightforward and easy. It says here, a right triangle has side lengths of 8 feet and 12 feet. How long is the hypotenuse? So that makes us a word problem is they didn't give us a picture, but they did a pretty good job describing that picture. A right triangle has side lengths of 8 feet and 12 feet. How long is the hypotenuse? We don't know how big the hypotenuse is, the longest side is. But once you draw your picture, you just go, oh, okay, that's pretty easy. A squared plus B squared equals C squared. Plugging in my longest side, that's my hypotenuse, that one, for the C. 8 squared plus 12 squared. That's 64 plus 144 equals x squared. That is something like 210. 64 plus 144, 208. That was close. And then I'm going to square root to make that x squared become just a plain old x. And so the square root of 208 is... Okay, so this is the first time we've got kind of a randomish looking answer. It's an irrational number. Remember that word from before, irrational. When you take the square root and you do not get a nice perfect answer, it's irrational. So we got an irrational answer of 14.422. I like just the hundredths place. And was there a label? Feet. And technically that's feet, and that's feet. So our hypotenuse was 14.42 feet. And I was looking at the picture. That makes sense because that's the longest side, and that number is bigger than the other numbers. I think we're good. Okay, so all you're going to have to do to kind of extend this is draw your own picture. Tom has drawn a right triangle with a hypotenuse of 17, while one leg is 8 centimeters. So let me draw that. So the hypotenuse is 17 centimeters and one leg is 8 centimeters. And I saw this is Tom and there's another person, Jasmine. So this is Tom and Jasmine. Jasmine drew a different right triangle with legs of 12 and 9. 12 and 9 centimeters. Who has the triangle with the largest perimeter? So to find who has the triangle with the largest perimeter, I would need to know all three sides. I would need to know how big this is, and then I could add all three sides up to find the perimeter. I would need to know how big this is, and add all three sides up to find the perimeter, and then figure out which perimeter is bigger. So that's kind of like my game plan. Now, to do it, well, I'm going to do Pythagorean Theorem. I'm going to do Tom here first. So a squared plus b squared equals c squared. Plugging in my largest side for c. Plugging in my other two sides for a and b. Solving the equation. Technically this is simplifying, but it's part of solving. 289, subtract 64 on both sides. I got the variable piece by itself first. 289 minus 64 is 225. And now when I square root both sides to get the x by itself, x is going to equal 15. So this side is 15, and I can find its perimeter now. The perimeter of Tom's triangle is what you get when you add all the sides together. 15 plus 17 plus 8 is 40 centimeters. So there is Tom's triangle. Tom's triangle has a perimeter of 40 centimeters. Okay, let's check out Jasmine. So a squared plus b squared equals c squared. Plugging in my longest side for the hypotenuse, that's just going to be my x. The other sides, and for a and b interchangeably. 81 plus 144 equals x squared. Is 225 again. Now, I'm still going to show the square root, but I'm not going to type it in a calculator because I know, because we've done this 3 times already this lesson, that that's going to be 15. I have it right here. Square root of 225 is 15. So this side is 15. Which means now I can find the perimeter of Jasmine's triangle. So the perimeter is what you get when you add all the sides together. So 12 plus 9 plus 15 is, I feel like this one's going to be smaller. Oopsie, I missed a thing. 12 plus 9 plus 15 is 36 centimeters. Now, for the actual answer to the question, who has the triangle with the largest perimeter? Well, Tom's perimeter is 40, Jasmine's perimeter is 36. That means Tom's perimeter is the largest. And there's our final answer. Okay, so that was a little bit more work. That wasn't just draw a triangle and find a missing side. That was a little bit more of an application to it, a little bit of a process. And that's okay. It's okay if there's a process, but we still had to do the Pythagorean theorem in order to find a missing side of a triangle. And we had to use that to find a perimeter and then compare perimeters. Here's one for you. It says a right triangle has a hypotenuse length of 9 kilometers and one leg has a length of 5. How long is the length of the other leg? Why don't you go ahead and pause the video, do this one right now. When you're ready to continue, hit play, and we'll go through it together. All right, so that's what you came up with. So a squared plus b squared equals c squared. Ooh, I didn't draw my triangle yet. Do, right angle. All right, it said the hypotenuse is 9 kilometers. That's your longest side. That's your C. One leg is 5. Okay, so now I know the 9 goes here, and then x squared plus 5 squared equals 9 squared. I don't need the equals again. So x squared, now I'm just solving, equals 81, x minus 25 on both sides. X squared equals 81 minus 25. It's too early in the morning to do the math in my head. 56. Okay, I know that that's not a perfect square. I know when I square root both sides here, and I get just plain old x equals, that this is not going to come out to a nice pretty answer, and that's okay. 7.48, and when I put it back in my picture to look at it, everything looks okay. Now, I didn't know which of these is going to be the largest side, but I do know that 9 is the biggest of the 3, so I'm making sure my answer kind of makes sense. If I got something bigger than 9, I whoopsied. And I haven't shown that yet. Let me show you now. Oh, get back here. Okay, so I'm just going to small him off to the side. Now, if you would plug in this 9 for the wrong spot, like we knew the hypotenuse, we knew the longest side was 9, but here's kind of a mistake that some people make. So if you did a squared plus b squared equals c squared, I said some people just throw the numbers always in for the a and the b. 81 plus 25 equals c squared. That's 81 plus 25. You see, it's kind of a difference here. We're subtracting the 81 and 25 the right way, and here we're adding them, which is the wrong way. C squared is 106, and then you would square root, and C is 10.2. Now, if you would take and you would draw that back in the picture, you go, wow, that hopefully you'd look at that doesn't make any sense, because 9 was supposed to be my largest side, but I just got something even larger than the largest side. That's the mistake that could have happened, okay? And that's a very common mistake in almost all of Pythagorean theorem for the next 4 lessons. So it's just something to keep in mind, that as you're finishing the problem, make sure your answer kind of works in the problem. All right. So this is all wrong. This one is the correct answer. Okay, here is another one for you. Why don't you go ahead and pause the video, do this one on your own right now, and when you're ready to continue, hit play, and we'll go through it together. All right, it says rectangle A. Drawing myself a rectangle. Rectangle A has a diagonal distance of 10 centimeters, so diagonal distance is 10 centimeters, and a height of 5 centimeters. Rectangle B has a diagonal distance of 12 centimeters and a base of 3 centimeters. Clearly my rectangle's not drawn to scale because if this is 3, I'm pretty sure this can be something bigger, but whatever, it's all fine. Which rectangle has the largest area? Did you do that? Did you actually find which one had a largest area, or did you just find missing sides? I don't know. That's a question for you. If you did not find which one had the largest area, you might want to go back and actually finish the problem. Now, for everybody else, we do have right triangles because in a rectangle, each angle is 90 degrees. So that means that this is a 90-degree angle. This is a right angle, which makes this a right triangle. Same there. And technically down here and all of them. So for rectangle A, I want to know its area. The area formula for a rectangle is length times width. That's this side times by this side. So you see the problem right away. We have the height, we do not have the base. So we're going to find the base. That's just the missing side of this triangle right here. So if I can find out how big this is, I can multiply my base and my height together to find the area. And again, Pythagorean theorem. So this gives me, let's see, there's my right angle. So across from it is the 10. This 10 is the hypotenuse. And then I guess technically this will be my x up here. X squared plus 5 squared equals 10 squared. Okay. 25, 100. So that was just doing the math. 5 squared is 25, 10 squared is 100. And that gives me, subtract 25 on both sides, and x squared equals 75. I'm going to square root both sides, and x equals, square root of 75 is 8.66, and I'm going to round it there. I like stopping at my hundredths place, so I would round my hundredths. So we did not get a nice pretty answer. Okay, so this side is 8.66 centimeters long. Now I can use that to find my area. Here's our area formula. So if I now plug my side lengths in, the length, 8.66, times by the width of 5, gives me an area of 8.66 times by 5, 43.3 centimeters squared. Okay, so that is rectangle A. Now, we repeat that process with rectangle B. So there's going to be my x. So I'm kind of focusing on this triangle down here. That 12 is my hypotenuse. So a squared plus b squared equals c squared. I plug my longest side in for the c. I plug the other two sides in for the other two sides. X squared plus 9 equals 144. I'm going to subtract 9. X squared equals 135 My brain's not working now. Double check it. There we go. I'd hate to make a stupid mistake and get it wrong. Square root, and x equals, if I square root 135, I get 11.62. So I rounded 11.6. I rounded the 1 up to a 2 because his buddy next door, the thousandths place, is a 5 or bigger. So I'm rounding to the nearest hundredths. That's what I like to round to. Centimeters. So 11.62. I'll put it over here because I don't have space, and these two sides are the same length, right? So now, using our area formula, we can find the area. Area equals length times width. Area equals 3 times by 11.62. Area equals 3 times 11.62 was 34.86 centimeters squared. Now, to actually answer the question, which rectangle has the largest area? Well, this one has an area of 43. This one has an area of 34. So the largest area would be this one. So we just need to say somewhere, rectangle A. There. Rectangle A has the largest area. There's our final answer. Took some work, took a little bit of multiplying and Pythagorean theoreming and stuff, but we got there. Summary. When using the Pythagorean theorem, what is the one side of the triangle that must always be in the correct place in the formula? If you said the hypotenuse, you're right. The hypotenuse, which is your longest side, must always go in for the C. So we can see that here. The longest side, the 10, has to go in for the C. The longest side here has to go in for the C. That's the only one that must be in the correct place in the formula, or else you're going to get the problem wrong. Okay? Thank you so much for watching this lesson on Pythagorean theorem. Until next time, toodles.